CapsFusion, rethinking image-text data at scale. Large multimodal models demonstrate remarkable generalist ability to perform diverse multimodal tasks in a zero-shot manner. Large-scale web-based image-text pairs contribute fundamentally to this success, but suffer from excessive noise. Recent studies use alternative captions synthesized by captioning models and have achieved notable benchmark performance. However, our experiments reveal significant scalability deficiency and world knowledge loss, issues in models trained with synthetic captions, which have been largely obscured by their initial benchmark success. Upon closer examination, we identify the root cause as the overly simplified language structure and lack of knowledge details in existing synthetic captions. To provide higher quality and more scalable multimodal pre-training data, we propose CapsFusion, an advanced framework that leverages large language models to consolidate and refine information from both web-based image-text pairs and synthetic captions. Extensive experiments show that CapsFusion captions exhibit remarkable all-round superiority over existing captions in terms of model performance. For example, 18.8 and 18.3 improvements in CIDR score on COCO and NoCaps. Sample efficiency requiring 16 times less computation than baselines. World knowledge depth and scalability. These effectiveness, efficiency, and scalability advantages position CapsFusion as a promising candidate for future scaling of large multimodal model training. Learning from mistakes makes LLM better reasoner. Large language models, LLMs, recently exhibited remarkable reasoning capabilities on solving math problems. To further improve this capability, this work proposes learning from mistakes, Llama, akin to human learning processes. Consider a human student who failed to solve a math problem. He will learn from what mistake he has made and how to correct it. Mimicking this error-driven learning process, Llama fine-tunes LLMs on mistake correction data pairs generated by GPT-4. Specifically, we first collect inaccurate reasoning paths from various LLMs and then employ GPT-4 as a corrector to identify the mistake step, explain the reason for the mistake, and correct the mistake and generate the final answer. Experimental results demonstrate the effectiveness of Llama. Across 5 backbone LLMs and 2 mathematical reasoning tasks, Llama consistently improves the performance compared with fine-tuning on COT data alone. Impressively, Llama can also benefit specialized LLMs such as WizardMath and MetaMath, achieving 85.4% pass at 1 accuracy on GSM 8K and 27.1% on Math. This surpasses the state-of-the-art performance achieved by non-execution open-source models on these challenging tasks. Our code, data, and models will be publicly available at the project's website. Beyond You, making diffusion models faster and lighter. Diffusion models are a family of generative models that yield record-breaking performance in tasks such as image synthesis, video generation, and molecule design. Despite their capabilities, their efficiency, especially in the reverse denoising process, remains a challenge due to slow convergence rates and high computational costs. In this work, we introduce an approach that leverages continuous dynamical systems to design a novel denoising network for diffusion models that is more parameter efficient, exhibits faster convergence, and demonstrates increased noise robustness. Experimenting with denoising probabilistic diffusion models, our framework operates with approximately a quarter of the parameters and 30% of the floating point operations, flops, compared to standard UNets in denoising diffusion probabilistic models, DDPMs. Furthermore, our model is up to 70% faster in inference than the baseline models when measured in equal conditions while converging to better quality solutions. Battle of the Backbones, a large-scale comparison of pre-trained models across computer vision tasks. Neural network-based computer vision systems are typically built on a backbone, a pre-trained or randomly initialized feature extractor. Several years ago, the default option was an ImageNet-trained convolutional neural network. However, the recent past has seen the emergence of countless backbones pre-trained using various algorithms and datasets. While this abundance of choice has led to performance increases for a range of systems, it is difficult for practitioners to make informed decisions about which backbone to choose. Battle of the Backbones, BOB, makes this choice easier by benchmarking a diverse suite of pre-trained models, including vision language models, those trained via self-supervised learning, and the stable diffusion backbone, across a diverse set of computer vision tasks ranging from classification to object detection to OOD generalization and more. Furthermore, BOB sheds light on promising directions for the research community to advance computer vision by illuminating strengths and weakness of existing approaches through a comprehensive analysis conducted on more than 1,500 training runs. While vision transformers, VITs, and self-supervised learning, SSL, are increasingly popular, we find that convolutional neural networks pre-trained in a supervised fashion on large training sets still perform best on most tasks among the models we consider. Moreover, in apples-to-apples comparisons on the same architectures and similarly sized pre-training datasets, we find that SSL backbones are highly competitive, indicating that future works should perform SSL pre-training with advanced architectures and larger pre-training datasets. We release the raw results of our experiments, along with code that allows researchers to put their own backbones through the gauntlet at the project's website. Unleashing the power of pre-trained language models for offline reinforcement learning. Offline reinforcement learning, RL, aims to find a near-optimal policy using pre-collected datasets. In real-world scenarios, data collection could be costly and risky. Therefore, offline RL becomes particularly challenging when the in-domain data is limited. Given recent advances in large language models, LLMs, and their few-shot learning prowess, this paper introduces language models for motion control, Llama, a general framework based on decision transformers to effectively use pre-trained language models, LMs, for offline RL. Our framework highlights 4 crucial components. 1. Initializing decision transformers with sequentially pre-trained LMs. 2. Employing the LoRA fine-tuning method in contrast to full-weight fine-tuning, to combine the pre-trained knowledge from LMs and in-domain knowledge effectively. 3. Using the non-linear MLP transformation instead of linear projections to generate embeddings. And 4. Integrating an auxiliary language prediction loss during fine-tuning to stabilize the LMs and retain their original abilities on languages. Empirical results indicate Llama achieves state-of-the-art performance in sparse reward tasks and closes the gap between value-based offline RL methods and decision transformers in dense reward tasks. In particular, our method demonstrates superior performance in scenarios with limited data samples. Our project's website is Project's website. SEINE, short-to-long video diffusion model for generative transition and prediction. Recently, video generation has achieved substantial progress with realistic results. Nevertheless, existing AI-generated videos are usually very short clips, shot level, depicting a single scene. To deliver a coherent long video, story level, it is desirable to have creative transition and prediction effects across different clips. This paper presents a short-to-long video diffusion model, SEINE, that focuses on generative transition and prediction. The goal is to generate high-quality long videos with smooth and creative transitions between scenes and varying lengths of shot-level videos. Specifically, we propose a random mask video diffusion model to automatically generate transitions based on textual descriptions. By providing the images of different scenes as inputs, combined with text-based control, our model generates transition videos that ensure coherence and visual quality. Furthermore, the model can be readily extended to various tasks such as image-to-video animation and auto-regressive video prediction. To conduct a comprehensive evaluation of this new generative task, we propose 3 assessing criteria for smooth and creative transition: temporal consistency, semantic similarity, and video-text semantic alignment. Extensive experiments validate the effectiveness of our approach over existing methods for generative transition and prediction, enabling the creation of story-level long videos. Project page, project's website. LoRA fine-tuning efficiently undoes safety training in Llama 2Chat 70B. AI developers often apply safety alignment procedures to prevent the misuse of their AI systems. For example, before Meta released Llama 2Chat, a collection of instruction fine-tuned large language models, they invested heavily in safety training, incorporating extensive red teaming and reinforcement learning from human feedback. However, it remains unclear how well safety training guards against model misuse when attackers have access to model weights. We explore the robustness of safety training in language models by subversively fine-tuning the public weights of Llama 2Chat. We employ low-rank adaptation, LoRA, as an efficient fine-tuning method. With a budget of less than $200 per model and using only one GPU, we successfully undo the safety training of Llama 2Chat models of sizes 7B, 13B, and 70B. Specifically, our fine-tuning technique significantly reduces the rate at which the model refuses to follow harmful instructions. We achieve a refusal rate below 1% for our 70B Llama 2Chat model on 2 refusal benchmarks. Our fine-tuning method retains general performance, which we validate by comparing our fine-tuned models against Llama 2Chat across 2 benchmarks. Additionally, we present a selection of harmful outputs produced by our models. While there is considerable uncertainty about the scope of risks from current models, it is likely that future models will have significantly more dangerous capabilities, including the ability to hack into critical infrastructure, create dangerous bioweapons, or autonomously replicate and adapt to new environments. We show that subversive fine-tuning is practical and effective, and hence argue that evaluating risks from fine-tuning should be a core part of risk assessments for releasing model weights. What's in my big data? Large text corpora are the backbone of language models. However, we have a limited understanding of the content of these corpora, including general statistics, quality, social factors, and inclusion of evaluation data, contamination. In this work, we propose What's in My Big Data, or YMBD, a platform and a set of 16 analyses that allow us to reveal and compare the contents of large text corpora. YMBD builds on 2 basic capabilities, count and search at scale, which allows us to analyze more than 35 terabytes on a standard compute node. We apply YMBD to 10 different corpora used to train popular language models, including C4, the Pile, and Red Pajama. Our analysis uncovers several surprising and previously undocumented findings about these corpora, including the high prevalence of duplicate, synthetic, and low-quality content, personally identifiable information, toxic language, and benchmark contamination. For instance, we find that about 50% of the documents in Red Pajama and Layan 2BN are duplicates. In addition, several datasets used for benchmarking models trained on such corpora are contaminated with respect to important benchmarks, including the Winograd Schema Challenge and parts of Glue and Superglue. We open source YMBD's code and artifacts to provide a standard set of evaluations for new text-based corpora, and to encourage more analyses and transparency around them. Project's website. The impact of depth and width on transformer language model. Generalization. To process novel sentences, language models, LMs, must generalize compositionally, combine familiar elements in new ways. What aspects of a model's structure promote compositional generalization? Focusing on transformers, we test the hypothesis, motivated by recent theoretical and empirical work, that transformers generalize more compositionally when they are deeper, have more layers. Because simply adding layers increases the total number of parameters, confounding depth and size, we construct 3 classes of models which trade off depth for width, such that the total number of parameters is kept constant, 41 million, 134 million, and 374 million parameters. We pre-train all models as LMs and fine-tune them on tasks that test for compositional generalization. We report 3 main conclusions. 1. After fine-tuning, deeper models generalize better out of distribution than shallower models do, but the relative benefit of additional layers diminishes rapidly. 2. Within each family, deeper models show better language modeling performance, but returns are similarly diminishing. 3. The benefits of depth for compositional generalization cannot be attributed solely to better performance on language modeling or on in-distribution data. Does GPT-4 pass the Turing test? We evaluated GPT-4 in a public online Turing test. The best-performing GPT-4 prompt passed in 41% of games, outperforming baselines set by ELIZA, 27%, and GPT 3.5, 14%, but falling short of chance and the baseline set by human participants, 63%. Participants' decisions were based mainly on linguistic style, 35%, and socio-emotional traits, 27%, supporting the idea that intelligence is not sufficient to pass the Turing test. Participants' demographics, including education and familiarity with LLMs, did not predict detection rate, suggesting that even those who understand systems deeply and interact with them frequently may be susceptible to deception. Despite known limitations as a test of intelligence, we argue that the Turing test continues to be relevant as an assessment of naturalistic communication and deception. AI models with the ability to masquerade as humans could have widespread societal consequences, and we analyze the effectiveness of different strategies and criteria for judging human likeness. Leveraging word-guessing games to assess the intelligence of large language models. The automatic evaluation of LLM-based agent intelligence is critical in developing advanced LLM-based agents. Although considerable effort has been devoted to developing human annotated evaluation datasets, such as Alpaca Evil, existing techniques are costly, time-consuming, and lack adaptability. In this paper, inspired by the popular language game Who is Spy, we propose to use the word guessing game to assess the intelligence performance of LLMs. Given a word, the LLM is asked to describe the word and determine its identity, spy or not, based on its and other players' descriptions. Ideally, an advanced agent should possess the ability to accurately describe a given word using an aggressive description, while concurrently maximizing confusion in the conservative description, enhancing its participation in the game. To this end, we first developed Deep to evaluate LLM's expression and disguising abilities. Deep requires LLM to describe a word in aggressive and conservative modes. We then introduced SpyGame, an interactive multi-agent framework designed to assess LLM's intelligence through participation in a competitive language-based board game. Incorporating multi-agent interaction, SpyGame requires the target LLM to possess linguistic skills and strategic thinking, providing a more comprehensive evaluation of LLM's human-like cognitive abilities and adaptability in complex communication situations. The proposed evaluation framework is very easy to implement. We collected words from multiple sources, domains, and languages, and used the proposed evaluation framework to conduct experiments. Extensive experiments demonstrate that the proposed Deep and Spy game effectively evaluate the capabilities of various LLMs, capturing their ability to adapt to novel situations and engage in strategic communication.